Hi guys, welcome back. Let's continue the organic effects lecture. In this lecture, we are going to be seeing mesomeric or resonance effect. Mesomeric or resonance effect is so important, and also it comes in three different places actually. One வந்து acidity, basicity of phenols பார்க்க போறோம். Then we have to also see electrophilic aromatic substitution and also stability of carbocation. In this lecture, I'm going to be doing one part of it, acidity and basicity of phenols and mesomeric effect related to that. Okay. In the next lecture, we will go to the next part. This slide is from the previous lecture as well, where are we going to see organic effects, and we have already seen inductive effect. We have seen this. We are going to be looking into the resonance or mesomeric effect. Both of the names are used. More so resonance India la use பண்ணுவாங்க, abroad la வந்து mesomeric effect they use, but they are interchangeable. And this has three different parts, as I told you. After we finish the three different parts, we'll go into hyperconjugation effect. Okay, what is mesomeric effect? So in inductive effect we saw, let's say for example there is a Z group attached, carbon கூட இருக்குன்னா Z வந்து electron withdrawing அந்த delta minus னு போட்டோம், delta plus along a covalent bond. Okay, sigma bond through நம்ம பார்த்தோம். அது electron density either increases or decreases on the carbon depending on Z, and we classified them as plus I minus I. Here we are going to do pretty much the same thing, the effect of electron density on particular position of a molecule. So in the first statement inductive ku resonance ku ஒரே மாதிரி இருக்கும். How we are going to do that is different. This is basically defined as the polarity produced, here also polarity produced in the molecule by interaction of, this is where the difference is, two pi bonds or between a pi bond and the lone pair of an electron present in the adjacent atom. Okay, and we will also see not necessarily two pi bonds, it could be pi bond and a lone pair. Later we will see it could be pi bond and charge. Carbocation, carbanion stability la we will going to see that later. The important difference between them is mesomeric effect is much stronger. Okay, much stronger than inductive effect, and it does not die down with distance. So inductive effect என்ன பார்த்தோம், fire பக்கத்தில் இருக்கிற example பார்த்தோம். The farther you go from fire, you're going to feel the effect. Okay, mesomeric effect does not change with distance, literally no change in magnitude with distance. Okay, this is something extremely important. However far you go, this is going to be the same strength pretty much. It's transferred along any number of carbon atoms, but the key here is transfer ஆகணும்னா conjugated system ஆகணும். Conjugated system is nothing but a network of pi and sigma bond alternative to each other. The best example for you guys is the Tamil game பல்லாங்குழி. பல்லாங்குழி விளையாடுனா உங்களுக்கு தெரியும், alternate empty slot இருந்ததுன்னா உங்களால் conjugation மாதிரி போக முடியும். That's what this is basically. The effect is used in a qualitative way and describes the electron withdrawing in releasing properties. Okay, it's just a statement. The thing that you want to know is the effect க்கு வந்து inductive I கொடுத்த மாதிரி இதுக்கு வந்து நம்ம M னு சொல்லலாம், R னு சொல்லலாம். Interchangeably I will use it, you also get used to it. More preferentially I stick with R because அந்த resonance என்ற வார்த்தைக்காக நான் R நிறைய யூஸ் பண்ணுவேன், but they are the same. Just like our inductive effect, there is two types of mesomeric effect, plus I, plus R, plus I minus I இருந்த மாதிரி இங்கே வந்து plus I பதிலாக plus M or plus R, minus I க்கு பதிலாக minus M and minus R. Now plus I was given by electron donating group. Here also the same. The electrons or the pi electrons are transferred from one particular group to the conjugated system. அதுதான் ஒரே difference. அங்கே வந்து it was through the bond, covalent bond through. So we have this, it was through the bond, correct? Here it's actually delocalization. So the thing that you want to remember, the main difference between inductive and resonance is, inductiveல இங்க இருக்கிற bond மூவே ஆகாது. The network of bonds stays the same. Bond order is pretty much the same because of inductive effect. It doesn't change. இப்போ உங்களுக்கும் உங்களுக்கு பக்கத்தில் இருக்கிறவங்களுக்கும் இருக்கிற bond order ஒரே மாதிரி தான் இருக்கும். உங்களுக்கு நடுவில் இருக்க electron மட்டும்தான் maybe it will be closer to you if you are more electronegative. Resonanceல the bond itself shifts, the pi bond itself shifts. Okay, you cannot shift a sigma bond, you shift a pi bond, and that is called delocalization. Localனா அந்த ஏரியால மட்டும் இருக்கிறது, delocalனா அந்த ஏரியால இல்லை. It is being moved out of that area into the next neighboring area, so it's called a delocalization of pi electrons or a lone pair. and if that delocalization increases the electron density, you call it plus M or plus R. Now obviously the most important example you're going to see is this one. So I made a separate statement. Aromatic compounds கொடுத்தாங்கன்னா plus R plus M group இருக்கு அப்படின்னா they affect only the ortho and para position, meta no effect. We are going to see this example. Here I'm giving you straight away the groups that give plus M or plus R effect. Okay. Now what is common in all of them? If you see, I need either I can donate a lone pair or a pi bond. So see here, this oxygen has 3 lone pairs. N O minus, correct? O minus. If you want, you can write it as N minus is stronger than O minus. எதனாலனா N minusல 3 lone pair இருக்கும். Sorry, 2 lone pair இருக்கும். O minusல 3 lone pair இருக்கும். Nitrogen is less electronegative. Okay, so they are more willing to give to the next person through resonance. Now, if you see here, all of them have lone pair, correct? Now you can generally see oxygen and nitrogen are more willing to give. Adala vandu nitrogen is more willing to give. But how come this nitrogen is not as good as this oxygen? That is because this nitrogen wants to give, but it is also held up by this resonance. This is called tied up in conjugation. Tied up in conjugation. Okay, you want to remember this is a amide functional group. Amide functional group, write down in your notes, the lone pair on nitrogen is tied up in conjugation, so the plus R is decreased compared to amine. So amine versus amide la amine wins over amide in plus R because of tying up in conjugation. Okay, one other thing that is missing here, I should rather write it here actually, OH. Okay, now you can see this is OH and this is OR. Who is more willing to give? ஒரே மாதிரி தான் lone pair இருக்கு. அப்போ இந்த O தான் நிறைய கொடுக்கணும் because plus I effect of R வேற இருக்குல்ல. But this wins. That's because of steric reason. Steric reason அப்படின்னா orientation or bulkiness of the group. இது பெருசா இருக்கனால இந்த lone pair is out of plane. Okay, planeலேருந்து வெளியில் போயிடும். இது planeலேருந்து வெளியில் போனனால effectively கொடுக்க முடியாது. Effective overlap இருக்காது. Hence OH wins. So OH versus OR, you want to remember important example. This comes many times. We will see an example later as well. OH always wins over OR. Particularly electrophilic aromatic substitution partல இது ரொம்ப முக்கியமாக வரும். I will mention that time also. Otherwise you can see, if you take this group, again the same O, C double bond O, R. Compared to this OR, this is lower, even though it is attached to a carbon because it wants to give, but the electron is also tied up in conjugation here. Just like here, it is tied up in conjugation. So anytime you have O, C double bond O, this is going to happen. இது எங்கெல்லாம் நடக்கலாம்னா OCO எங்கெல்லாம் வரும்? OCO, OH, OCO, O. Okay, anytime you have ester, அதுதான் இங்கே கொடுத்துருக்கு, or I can have O, C double bond O, O something, anything at all. Okay, we will see them in detail later. Now how does the resonance work? Take phenol for example. Phenol வந்து இந்த hydrogen போச்சுன்னா O minus வரும். That's what I have drawn here. See, now this can be sent here and this can come here, correct? So it's stabilized by resonance. Now this can go here, this can come here. நீங்க எதுவுமே வரைய வேண்டாம். நீங்க just put this arrow in a different colored pen from the notes I have sent you. You will be all right. Okay, now this is how it is going to rotate. Okay, negative charge can be delocalized. Because it can be delocalized, meaning instead of one place, it is in multiple places. Because it is delocalized, this is going to be stabilized by resonance. உங்களை ஒருத்தங்க ஸ்டேபிள் ஆக்குறாங்கன்னா நீங்கள் அந்த ஃபார்மில் இருக்க விரும்புவீங்க, correct? So somebody is stabilizing you, meaning I would more likely to become this structure because I'm stabilized. Hence phenol gives it up easily compared to other alcohols. Just like our plus M or plus R effect, minus M or minus R is basically taking electron away because of resonance. If I take it away, the electron density decreases. Same goes here. Okay, everything is the same. Electron withdrawing group by delocalization. Through sigma bond minus I, delocalization minus R. Aromatic adhe mari da, electron density decreases. Or minus M group irukuna, the electron density decreases at the ortho and para position only. Metal no effect. This is what you're going to have. Now you can see what is the similarity in all of them. You don't have to memorize crudely. Similarity irukum. Ellathukkume similar enna, in the first atom pakathula, along with the first atom, there is a double or triple bond. You will see N double bond O, correct? C triple bond N. Similarly, sulfur, double bond O, OH. C double bond O, H. C double bond O, R. C double bond O, O, CO. C double bond O, O, R. Okay, it keeps going this way. Alright, so this is how it is going to go. C double bond O, O, H, it keeps going this way. So minus M effect. Now, you can see that this is 3 electronegative atom stronger. This sp hybridization strong. Now this is also, if you look into it, sulfur la 3 oxygen. So all of them are pulling, so this is a strong effect. Now you want to look at these particularly. It's very simple. C double bond O ellathillume irukilla. Now, how is the order? The order is decreased when the C double bond O is attached to an atom that has lone pair of electron or electrons. Edella irukkalam, oxygen irukkalam, illa nitrogen irukkalam. Why? If there is a lone pair, I'm talking about the group here. This is taking electrons நம்ம சொல்றோம். இங்க இருக்கிற electron வந்து it is going to take. I'll show you in a minute. It's going to take. Because of that, I say this is minus R group. But what if on this side, this is U, okay, understand this is U, நீங்க வந்து electron வாங்க போறீங்க, you are minus R. But what if on this side somebody is giving you, உங்களுக்கு இந்த பக்கம் ஏற தராங்கன்னா இந்த பக்கம் நீங்க effectively வாங்க மாட்டீங்க. So உங்களோட minus R effect கம்மி ஆகுதுல்ல? That's what happens when you have oxygen and nitrogen. Now who will give more, oxygen or nitrogen? Nitrogen will give more. Hence I have nitrogen here. Who will give even better than nitrogen? O minus. We have seen this before. O minus N. Now if you see here, இது எல்லாமே oxygen தான் இருக்கு. Correct? So I have oxygen. Oxygen is going to give. So இந்த effect உங்களுக்கு வந்து கம்மியாக போகுது. So it's going to decrease because of this. Okay? This is U. Understand this. This is U. நீங்க இந்த லெஃப்ட்ல இருந்து வாங்க போற effect கம்மியாக போகுது because right sideல உங்களுக்கு compensate பண்றாங்க. Okay? Now who will compensate better? If this group gives to oxygen, oxygen will give to this. What will give to oxygen easily? Okay. Take for example here, hydrogen தான் attach ஆயிருக்கீங்க, correct? Won't give much. R group will give much easy. So this is normal. இங்கே போகும்போது தான் oxygen இருக்கு. Okay. If you see here, this oxygen, nobody is giving to this oxygen, they are taking away. CO வந்து minus I னு பார்த்தோம். Also we can see that this is going to go this way. In the example particular பார்க்கலாம், but at least you know somebody is taking away. அப்போ இந்த oxygen இந்த பக்கம் கொடுக்காது. So effect is decreased this side, so minus M is stronger. இங்கே போகும்போது இது plus I, oxygen கொடுக்க போகுது. So if somebody gives to this oxygen, the oxygen gives to this side, left side effect is decreased. Somebody takes away from oxygen, oxygen doesn't give this side, so you will take away only from left side, the effect of minus M is increased. Now who will take away from oxygen? C double bond O. Okay, so now what you want to do is arrange them in the order, draw clearly, and then write it as, for example here, what is the effect of this one? Minus I. Idu plus I. Okay, idu plus I. All this will give easily, so decrease. This will take away, so increased. Okay, here purely double and triple bond, so extremely high. Now how does it take? So here is a representation of how it is going to take. You can see here NO2 group ringல இருந்ததுன்னா ring deactivate பண்ணும். இதோட name வந்து deactivating the ring. It is taking away from the ring. So the NO2 is a minus R group. It takes electron away from the ring. Okay, because of conjugation. O minus, and that O minus is stabilized in 3 different resonating structures. Okay, all this is theory. Theory வந்து confusing இருக்கும். Hence I actually have examples here. We'll go one by one. So இது amide group இருக்கு. As I told you, this amide nitrogen lone pair is tied up in resonance with C double bond O. Now you can see two different things. What effect is it? Depending on where you are looking at. நீங்கள் C double bond O நீங்கள் ஃபோக்கஸ்டாக இருக்கீங்க அப்படின்னா amide வந்து என்ன பண்ணுதுன்னு நீங்கள் லேபிள் பண்ணணும். நீங்கள் amide பார்க்குறீங்கன்னா NH2O பார்க்குறீங்கன்னா C double bond O என்ன பண்ணுதுன்னு பார்க்கணும். So let's say I'm focusing on C double bond O. What's happening to it? What's NH2 doing? Giving electrons. So NH2 is a plus R group. Okay, so that's what has happened. Now reverse பார்க்கலாம். I want to look at the basicity of this nitrogen. Basicity na இந்த electron வந்து நாம் Lewis acidக்கு கொடுக்கணும். We saw this last week. இதை நான் தரணும். But இந்த electron வந்து ஃப்ரீயா இல்லை. It is actually taken away by C double bond O group. So C double bond O group is a minus R group. So you see plus R and minus R are within an example itself. இப்போ நீங்கள் வாங்குறீங்கன்னா யாரோ ஒருத்தங்க கொடுக்குறாங்க. Okay, there is nothing like you taking your minus R and that is done. If you are taking it, somebody is giving. It comes down to who we are focusing. இன்னைக்கு எக்ஸாம்பிள் உங்களை ஃபோக்கஸ் பண்ணுறோமா இல்லை உங்களுக்கு கொடுக்குறவங்களை ஃபோக்கஸ் பண்ணுறோமான்றதை பொறுத்து ப்ளஸ் ஆர் மைனஸ் ஆர் எழுத போகிறோம். ஓகே, ஸோ ஐ டூ ஒன் மோர் டைம். இந்த C double bond O ஃபோக்கஸ் பண்ணுறோன்னா அந்த C double bond O சுற்றி இருக்கிறவங்களாம் என்னென்ன பண்ணுறாங்கன்னு பார்க்கணும். ஓகே, ஸோ வில் ஸ்டார்ட் அகெயின். ஸோ இஃப் ஐ எம் ஃபோக்கஸிங் ஆன் C double bond O, let me label both sides. What is NH2 doing? Plus R. What is the alkyl group doing? Plus I. Okay. Now what about C double bond O group doing to NH2? It is a minus R group. What is the C double bond O doing to the R group? Minus I group. Okay, it's all within the same parameters. Now you want to remember amide is a poor base than amine because the lone pair on nitrogen is again tied up in conjugation with carbonyl group. So this word you want to remember, tied up in conjugation. Because of that the basicity of amines is higher than basicity of amide. Okay, now let's go to NO2 group. So the NO2 is pulling electrons from, let's say this is our system. This is our system. What is the NO2 doing? Pulling electrons. Is it pulling through minus I effect? Yes. So NO2 is a minus I group. But it is also pulling through resonance. So it is also a minus R group. You want to remember NO2 is a minus I minus R group. We will look into tiebreaker soon. எப்போ எதை decide பண்ணணும்னு. Now if NO2 is minus I, what about this group? Plus I னு சொல்லலாம். Or NO2 is minus I minus R இங்க, அப்போ இந்த group plus R because it is giving electrons, right? So this is plus R. This is taking electrons, so this is minus R. Okay, you want to remember double bond இருந்ததுன்னா அதை கொடுக்க முடியும். அதால் if I have pi electrons I can give it to somebody, so I am a plus R group. Now let's go to a carbonyl group in acrolein. Acrolein is this molecule, CH2 CH2 double bond. Okay, this carbon is here, then I'm going to draw this carbon, C double bond O H. This is acrolein. 1 2 3, so there is a CH here. Okay, so this electron can come here, this electron can go there. So the CO is a minus R group, idu vandu plus R group, depending on where you are looking at. Now I'm basically looking at here means I would say this is minus M effect of the carbonyl group. Why carbonyl takes is oxygen can handle a negative charge very well. Okay, but oxygen is not always a taker, it is also a giver. For example, in this case, if you see here, oxygen has lone pair, and the lone pair on the sometimes they do it this way or they do it this way. I'm trying to show you both ways. இப்படி லைன் போட்டாலும் lone pair தான். This lone pair is in conjugation with the double bonds. Okay, so it can be given So I can get this structure. So right now the oxygen is behaving as a plus R group if the oxygen is giving. So usually oxygen eppalam kudukonna OH, OR arna kudukum. Here what do I have? OR. Oxygen eppalam it can take electron is when it is a C double bond O group. C double bond O irukku abdina it can take. C single bond O with let's say hydrogen, it can only give. It cannot take. Okay. Now we can draw it this way. Why it cannot take? Let's say for example I have this. Okay. I'm telling you I can give. Okay, got it. Why it cannot take? Oxygen has 2 lone pairs, 2 sigma bonds, correct? Now if this gives, what will happen? In the bond move panna mudiyadhu, sigma bond. So oxygen mela idha panningana, how many electrons does oxygen have now? 2, 4, 5, 6, 7, 8 already. This important 10 octet violate agum. So a single bonded oxygen like this cannot take electron. It is always a plus R group. Now it is not going to be this difficult. You're going to get used to it so fast. Examples paakumbodhu this will get clear. At this point it is too much information, I know. This is a particularly confusing effect, but you will get there soon. Now where all can we see stabilization of charge, C double bond O. So in the charge irukana, see always you're going to see this double, single, double, something like this, or double, single, lone pair, or double, single charge. Basically double, single, அடுத்து இருக்க போது double ஆவோ lone pair ஆவோ charge ஆவோ இருக்கலாம் பல்லாங்குழி மாதிரி. So that single one acts as a buffer. Okay, same thing here. Charge irukku, the charge can come here, this can take here. So this carbon ion is stabilized. Now this may seem simple to you, this carbon ion, but it is actually not. Where you're going to see this is, this is from acetone. Acetone la வந்து ஒரு base போட்டிங்கனா இந்த hydrogen போய்டும், alpha hydrogen. This actually ends up giving you aldol later. Okay, this is the importance of alpha hydrogen, importance of resonance effect, all those. Aldol will be given faster by aldehyde or a ketone. You're going to see all this later. Okay, இது வந்து இங்க ஒரு hydrogen the aldehyde, correct? Now put this here. Now we are going to look at stabilities later. அப்போ பார்க்கும்போது aldehyde ketone அந்த order என்னன்னு தெரியும். To get there you have to get these effects very strong. Here is a quick comparison of inductive versus resonance effect. A group may possess both R and I effect. Okay, as I told you, this can be possible for a given group and sometimes opposing, meaning nitro எடுத்துக்கிட்டீங்கன்னா it's minus I minus R. Okay, but we saw OH, it's minus I plus R. Halogens are minus I plus R. So all this, so it can be opposing or same. In most cases resonance effect is stronger and outweighs inductive. For you guys it is almost all cases. NEET la higher level la போகும்போது தான் there is a competition. For example OH NH2 la எடுத்தீங்கன்னா it has lone pair. So right away when you see lone pair you want to label it as plus R. And the atom, first atom attached to the carbon atom here is electronegative atom. So minus I. That's what it is saying here. Since plus R is much stronger, because I just told you here plus R is stronger than minus I, net result enna abdina OHO NH2O irundaduna you're going to say it is a electron releasing effect na solla porom nama. So for example, if I take a ring, okay, I have OH group. OH is plus R minus I. So what is the net effect on the ring? Electron density is increased because plus R outweighs the minus I. Alright, that's what I can see. Few cases alone the resonance effect is weaker than inductive effect. Example, halogen atoms. For a variety of reasons, let's take fluoro, chloro. நீங்க chloro experiment பண்ணால bromo nido சொல்லிடலாம். Okay, this is a very strong minus I because electronegativity is very high. Very strong minus I, so it is almost equal to its plus R மாதிரி வச்சுக்கலாம். Chlorine is minus I but not as strong as oxygen. Okay, chlorine is also plus R. அப்போ ஆக்சிஜன் மாதிரியே தான் இருக்கணும்னு சொல்லலாம், ஏன்னா இண்டக்டிவ் எஃபெக்ட் ஆக்சிஜனோட கம்மி. பட் த ப்ராப்ளம் ஹியர் இஸ் the chlorine giving to carbon is not effective because chlorine is a third period element. Okay, first period la halogen kadiyadhu, hydrogen helium, second period la fluorine irukku, third period la chlorine irukku. So the chlorine electrons, the lone pair of electrons are on 3p orbitals. Carbon is a 2p orbital. Imagine a 2p and a 3p overlapping, not effective, ஒரே சைஸ்ல இருக்கணும்ல. Because of that it's not a very strong plus R. Minus I is same as oxygen which actually nitrogen. Minus I is same as nitrogen for chlorine, but the plus R is not strong. So because of that, their plus R is actually less than minus I. Okay, we will look into this particular example later in electrophilic aromatic substitution. At this point, just know this. Halobenzenes are less reactive than benzene towards electrophilic aromatic substitution. Okay, when we learn about EAS, you will actually understand why this matters. Right? Okay, what are we going to see in this lecture based on these effects? Now, நீங்க crude வந்து எது plus R எது minus R group நீங்க ஞாபகம் வச்சுக்கிட்டா கூட போதும். But it is better that you understand why they are doing. I showed you before. This lone pair can be given inside. Okay, can be given here. So minus sign இங்க வரும். And the minus sign conjugation. You do not have to draw this like structure ever. Just know how it is doing. All you want to know is where are the electron densities rich. It's going to go to ortho, para and ortho. Meta is always skipped. Only ortho and para are electron rich. You want to remember that. Okay, we are going to see this later. Now, because this conjugation is possible, oxygenal இந்த எலக்ட்ரானை கொடுக்க முடியும்னும் போது இந்த எலக்ட்ரானை வாங்கிக்க முடியும் அதால. And let the hydrogen go. Hence, phenol is a stronger acid. That's one way of seeing. Second way of seeing is, let's assume that it has given out the hydrogen. Phenoxide ion வரும். The phenoxide ion is stabilized by resonance. Anytime something is stabilized by resonance, it's willing to go there. Let's say, for example, உங்கள்கிட்ட இருக்கிற hydrogen நீங்க கொடுத்துட்டீங்க, நீங்க phenoxide மாறுறீங்க. Once you change to phenoxide, it is being stabilized, meaning you are more willing to give compared to a plain ROH. Ethanol edutha, this is what I get. Is this ethoxide ion stabilized? No, ena idu vandu plus I. Okay, plus I, not stabilizing. What is the effect here? Now this is what you want to look at. Phenol or acidic strength பார்க்கும்போது, this is what we are looking at in the position. அப்போ அது கூட அட்டாச் ஆயிருக்க எல்லாரையும் லேபிள் பண்ணணும் நம்ம. Okay, so I have to label the ring. This is the most confusing thing. Electrophilic aromatic substitution போகும்போது நம்ம இங்கே பார்க்க போகிறோம், வெளியில் இருக்கிறது என்னன்னு லேபிள் பண்ண போகிறோம். அசிடிக் ஸ்ட்ரென்த்தில் அசிடிட்டி OH குரூப்னால இதை பார்க்க போகிறோம், எல்லாரையும் லேபிள் பண்ண போகிறோம். What is the ring doing? The ring is taking away electron. So the ring is a minus R group. Ring is a peculiar one. It can be plus R or minus R depending on need. Inga need enna electron withdraw pananum. So it ring is a minus R. Minus R groups, just like minus I, increases acidity. So we can write acidity is proportional to minus I minus R, inversely proportional to plus I plus R. What else is acidity proportional to? Percent S character. இதையும் நம்ம பார்த்தோம். Write this down. Okay. Now this is an example. Phenol versus cyclohexanol. பார்க்க ஒரே மாதிரி இருக்கு. ஆனால் in cyclohexanol it is actually no resonance possible. In phenol resonance is possible. Because of that, phenol is more acidic than cyclohexanol. Okay. That's what you want to say. pKa பார்த்தீங்கன்னா கம்மியாக இருந்ததுன்னா அசிடிக்னு. Phenol is actually acidic, cyclohexanol is not acidic at all. It's just a comparison. Okay, here is a summary of what you want to remember. Basically, a minus R group at ortho and para increases acidity. So உங்களுக்கு என்ன இருக்கணும்னா எலக்ட்ரான் வித்ட்ராயிங்காக இருக்கணும். We saw acidity is proportional to minus R. அது ortho and para இருந்தால் மட்டும்தான் வரும். மெட்டால ஸ்கிப் ஆகும். That also we saw. I'm pulling them together. Opposite வந்து plus R இருந்ததுன்னா decreases acidity. We wrote this down. Why there is a resonating structures here? Just to look at it, you don't have to draw any of them in NEET exam. Okay, so this electron is moved here. Okay, this electron is put here, other the minus. Now this minus can move to here. NO2 is this, correct? It can move here and move here. So NO2 is stabilized by resonance. And where all this can happen? NO2 is in ortho position or para position. I chose an example where there is two NO2s, doesn't matter. So now this is cyclohexanol is less acidic than phenol. Okay, phenol ku nama minus R irundha better. So now I'm going to label them. This is what we are going to learn now. உங்களுக்கு கொடுக்குமோ இந்த மாதிரி தான் கொடுப்பாங்க. What is your reference here? Phenol. This is phenol. I am focusing on phenol. What do I have to label? I have to label this. These are the groups attached to phenol, right? Okay, so now I'm going to label them. What type of effect is OCH3 ether? It is minus R, sorry, it is plus R minus I. Plus R because it is giving minus I. But I can drop the minus I because para position is far away from here, fourth carbon, correct? 1, 2, 3, 4. Okay, so this is actually dropping, so plus R. What is chlorobenzene? This is weak plus R, weak minus I. What is this going to be? C double bond O irundadunale minus R minus I. NO2 is minus R minus I minus R minus I minus R minus I. இங்கே வந்து ரெண்டு இருக்கு. Here, okay, here minus R minus I. Minus R minus I எழுதணும்னு பார்ப்போம். This is in meta position, so there is no meta position, only ortho and para, so only minus I. Okay, இங்கே நான் minus I drop பண்ணிடலாம் because it is far away. Now among them, if you see who has the most number of minus R, this molecule. So this will be the most acidic. Yes, pKa ரொம்ப கம்மியா இருக்கு. Then which one is going to be this particular one? Because ரெண்டு minus R இருக்கு. Then I go, what about minus R? Where else is minus R? இங்கே minus R அல்ல, இங்கே இருக்கு minus R, இங்கே minus R இருக்கு. Who is stronger minus R? NO2 is stronger, so next lowest pKa compared to this. Then I go to this minus R. All my minus R's are done. Then I look at my I effect, minus I. So hence this comes. Okay. Next is between these two. They are no minus I because they are far, but they are plus R. Who is stronger plus R? This is stronger plus R. So it is going to decrease. So நீங்கள் order எப்படி எழுத போறீங்கன்னா minus R group முதல்ல பார்க்கணும். These phenols are more acidic compared to minus I phenols, compared to phenol, compared to plus I, compared to plus R. Okay. Now we are going to do it again. Now this time differently. We're not going to box. We are going to just look at it. Okay. Now let's say, for example, we say it as 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 molecules. Let's say they will give you only 4. I'm giving you 9 here. We're going to label them. Okay. This is minus R, minus R, minus R, minus I. This is minus R minus I. இது வந்து மெட்டால மட்டும் இருக்கனால மைனஸ் ஐ. இது பேரால இருக்கனால வெறும் மைனஸ் ஆர். ஐ கேன் ட்ராப் தீஸ் ஐ வேல்யூஸ். இது பேரால இருக்கனால வெறும் மைனஸ் ஆர். பேரால இருக்கனால வெறும் ப்ளஸ் ஆர், ப்ளஸ் ஆர். ஓகே. நவ் கோ ஃபார் மைனஸ் ஆர். 3 மைனஸ் ஆர் இருக்கனால 9 இஸ் தி ஸ்ட்ராங்கஸ்ட் ஆசிட். 2 மைனஸ் ஆர் இருக்கு, 8. Then 6 and 5 have both as 1 minus R, but 6 is NO2 minus R stronger compared to 5. So all the minus R are labeled. Next என்ன சொல்லணும்? Minus R, minus I, phenol, plus I, plus R. Minus I மட்டும் எதில் இருக்குன்னா number 7. Then phenol, number 2. Then plus I. ப்ளஸ் ஐ வந்து முக்கியம் இல்லை, இங்கே ப்ளஸ் ஆர். ப்ளஸ் ஆர்லேயே வந்து கம்மியாக இருக்கணும். ப்ளஸ் ஆர் எதில் ப்ளஸ் ஆர் கம்மியாக இருக்குன்னா 4ல் கம்மியாக இருக்குது. பிகாஸ் திஸ் இஸ் ஸ்ட்ராங் ப்ளஸ் ஆர். எனக்கு ப்ளஸ் ஆர் வேண்டாம். ஸோ இது ரெண்டுத்து கம்பேர் பண்ணும்போது திஸ் இஸ் பெட்டர். So my 4 greater than 3 greater than 1. Okay. Now compare your pKa values. It will match exact opposite because pKa வந்து அதிகமாக இருந்ததுன்னா acidity கம்மி. So this is how you're going to get. You don't have to memorize pKa values. It's just for reference. I have given you these values. Okay. Now orthonitrophenol is a special case you want to remember. Phenol பார்க்கும்போது orthonitrophenol. Now generally I am going to look at phenol separately, or sorry, I would rather say nitrophenol separately. Nitrophenol போகும்போது நம்ம என்ன பார்க்கலாம் அப்படின்னா, all nitrophenols are going to be more acidic than phenol. Okay, now I have NO2, NO2, NO2. Now what are the effects here? Minus R. Okay, this is minus I, this is minus R, minus I. Okay, now ரெண்டு மைனஸ் ஆர் இருக்கும்போது நம்ம எப்படி டிசைட் பண்ணணும் அப்படின்னா, நெக்ஸ்ட் எஃபெக்ட்டுக்கு போகணும். அப்போ தான் ஐ யூஸ் ஆகும். அப்போ மைனஸ் ஐ இதுக்கு அதிகமாக இருக்குல்ல. ஸோ திஸ் ஹாஸ் டு பி த மோஸ்ட் அசிடிக். பட் ஃபீனால் கேஸ் மட்டும் நீங்கள் ஞாபகம் வச்சுக்கணும், பேரா இஸ் மோர் அசிடிக் தேன் ஆர்த்தோ, மோர் தென் மெட்டா. மெட்டாவில் மைனஸ் ஐ மட்டும்தான் இருக்குது, இது ரெண்டுத்துலேயும் மைனஸ் ஆர் இருக்குது. பட் த ரீசன் தட் ஆர்த்தோ இஸ் ஆக்சுவலி ஈவன் ஹேவிங் மைனஸ் ஐ இட்ஸ் நாட் ஸ்ட்ராங் இஸ் பிகாஸ் அசிடிட்டினா நான் இந்த ஹைட்ரஜன் போகிற ப்ராப்பர்ட்டியை பார்க்க போகிறோம். Correct? The hydrogen going out, but the hydrogen is held by hydrogen bonding. Intramolecular hydrogen bonding is extremely important example that comes in NEET in orthonitrophenol. So orthonitrophenol வந்து intramolecular hydrogen, intrana உள்ளுக்குள்ளே இருக்கிறது, hydrogen bonding இருக்கிறதுனால it is going to be not very acidic compared to para. You want to remember this order. Okay, the few other order you want to remember, I have given you the pKa values. Don't memorize them, just look at the order. Trinitrophenol is 3 nitro groups, extremely strong, that it is much stronger than acids itself. Acid namo COH group இருக்கும். Phenol is not a COH group, it's just a OH group, but it gets stronger, so strong. So you want to remember picric acid is much stronger. Now we know acetic acid or trichloroacetic acid is good. Trichloroacetic acid is so good that it is better than formic acid itself. Now you take formic acid and then you take benzoic acid and then you take acetic acid. How do I decide between them? This is plus I, this is minus I, this is weak plus I. Okay, so because of this I should say this is the weakest, this is the next to weakest, இது minus I stronger இருக்கும். But this order is flipped. You're going to see that soon. Okay, remember this order. In the numbers table, in the order ஞாபகம் வச்சுக்கணும். I'll actually give the entire order after I finish the entire organic effects lecture as well. I'll send it as notes. You need to know why. Notes la memorize பண்றதுக்கு பதிலா why ன்றதை புரிஞ்சுக்கிட்டீங்கன்னா you will be able to recollect it anytime. Alright, now that we saw acidity, don't worry, you will see examples soon. Basicity பார்க்கலாம். Basicity of amines is also the important property. Now we know that when it comes to basicity, we have seen this last week. Inductive effect பார்க்கும்போது I told you that alkyl amines are stronger than ammonia, which is stronger than aryl amines. Aryl is minus sign upper சொன்னேன், but it is also one more thing. See, it can withdraw the electrons, right? So this is also minus R group. It withdraws electrons. So because of that, the basicity of aromatic amine decreases compared to even ammonia. Okay, so nitrogen இருக்கிற lone pair வந்து வெளியில் கொடுக்கறது பேர் தான் basicity. நான் அதால் effective வெளியில் கொடுக்க முடியாது because உள்ளே அது வாங்கிடுது. Okay, alright, so because of that we can say that aromatic amines are not as good. Now how can I make it even more weaker? By adding in the ringல வந்து electron withdrawing group at ortho and para will pull the electron more, so basicity decreases. Now what about if I put electron donating group at ortho and para? Electron donating group donates electron, like this withdraws electron, this donates electron. இது electron donate பண்ணா ring வந்து electron வந்து இதிலேருந்து வரதுனால நைட்ரஜன்லேருந்து அதிகமாக எதிர்பார்க்காது, so basicity increases. So or in a nutshell, electron donating group in aniline increases basicity, electron withdrawing group decreases basicity as long as they are in ortho and para position. Now here is an example where I have shown you resonance stabilized amines are less basic. These are resonance stabilized. I can stabilize it by resonance on both sides, right? In the ring conjugation, in the ring conjugation. So this is the least basic. The more the nitrogen is in conjugation, the less the basic it is. One more example of resonance stabilized is not an amine, amide. Same, correct? I told you amides are worse than amines. Same here. All right. Here, this is purely, what type of amine is it? This is RNH2, primary amine. A primary amine is stronger than ammonia. Ammonia is stronger than aromatic amines. Right away when you see NH2 group, you need to figure out what degree of the amine is it. Okay, here I am just reiterating what I just said to you. A minus R group at ortho and para decreases basicity. NH2 la irukra lone pair ring vaangudhu. Ring kitta indha vera yara vaangananga ring vandu innum konjam greedy ah and electron ulla pull pannum. That's what is shown here. And it has to be in ortho and para position. So simply the NO2 neenga ortho illa para la pathinga illa or minus R group pathingana basicity is less. That's all. More the number of NO2, more decrease the basicity. Yes. Now here if you see, I have para, meta and orthonitroaniline. Now here I have given you a specific example here. Now what I am going to do is, what is common in all of them? Aniline group is common, NH2 ring is common. So I have to label this group. What is this? Minus R. What is this group? Metal erna minus I. What is this group? Minus R, ortho minus I vara irukum. So it is withdrawing electron extremely. So this is the worst base. Okay. Don't worry about this number. It's actually opposite of pKa na the kudutadukku appuram varadhu. You can say it this way. Basicity la edu vandu stronger irukona metanitroaniline is stronger than paranitroaniline, which is stronger than orthonitroaniline. You want to remember this. In the ordering opposite irukku pKa H idu. This is a little different. We will get to this later. Okay. At this point at least you want to know, what if I give you pKb? pKb values appo edhukku adhigama irukum? Meta is less than, para less than ortho. Why pKb adhigama irundha basicity kammi? All right. Just like minus R group decreases basicity, a plus R group increases basicity because somebody is giving to the ring. Like here, somebody is an electron donating group at ortho or para, gives to the ring. So the ring doesn't want much from this. So this is inhibited. No need much. Okay, because this is given to NH2 group. This will give it to somebody else. So better base. So electron donating group makes it a better base. The more strongly the electron donating group, the greater the basicity. And we know that more stronger is NH2. So inge innor NH2 irundaduna innu stronger irukum. Okay. Now we know these. Pyridine la munadiye paathutom. I am just reintroducing this. So pyridine la irukku. Now what if I have OCH3? This will give electron here. This will give electron here. Okay. So electron density on this nitrogen is extremely high. And inge vandaduna, this nitrogen will take the electron here, extra electron minus. What will happen? It will easily give. So 4-methoxypyridine is a stronger base. Now what about this? This is even stronger. Why? Oxygen, compared to pyridine, oxygen irukradanaala basicity adhigamagudha, nitrogen irukradanaala innume adhigamagum. This is given, this is given, this is on nitrogen. You don't need to draw any of them, understand again. Just ungalku kuduthirukka notes la indha arrow mattum vera color la potukkom. So basicity increases when a strong electron donating group is in the ring in the conjugated position of ortho and para. Aniline edutha adhe mari dhaan. Aniline oda compare panna this is better para-methoxyaniline. Okay, or para-amino anisole. Now this gives electron, this gives electron, this gives electron. Okay, because of that this electron can be given away easily. Actually it's not right way to draw this, leave it. Okay, similarly this can give even easier. Okay, so because of that the electron can be given out. So the basicity order is this way. That's all. They will print the molecule. Basicity order மட்டும் தான் பார்க்கணும்னா இந்த arrow போட வரைஞ்சிக்கிட்டீங்கன்னா examல you're going to do the same thing. Alright, now this is how you're going to get stronger. So for what we have learned, what I would do if I were you is I'll pause the lecture, watch it one more time before I get here. நீங்க அதில் ஸ்ட்ராங்காக இல்லைனா இது வேஸ்ட் பண்ணிடுவீங்க. Okay, now hoping that you have watched it 2 times and written your notes, let's look into it. Among the following 4 compounds, acidity order கேட்குறாங்க. First thing you want to look at is you want to see whether there is acid itself. Phenol is not as strong as acid except picric acid. இதில் எதுவுமே acid இல்லை. Looking at phenol, metanitro, methylphenol and paranitrophenol. Do not draw any of them. Okay, all we know is phenol reference. Methylphenol, methyl is going to be plus I effect. Nitro is going to be, metanitro is going to be minus I. Paranitron is, minus R effect. What is the best one that we can have for acidity? Minus R followed by minus I. So we know that minus R, minus I, phenol, plus I, plus R. So minus R is delta, greater than Charlie, greater than alpha, greater than beta. That's all. 2010 question. See how இது வந்து நீங்கள் ப்ராக்டிஸ் பண்ண this will take you less than 10 seconds. Which of the following compound has the most acidic nature? So all of them are OH group. Alcohol acidity கேட்குறாங்க. Now we know that alkyl alcohols are not acidic. Phenol is acidic. That's all. This is not alkyl alcohol. This is actually, this is not phenol. This is alkyl alcohol. So it is not going to be great. Now we can actually, what we can do, we can arrange them in order. 3 is the strongest acid, followed by carbon attached to the OH should not have electrons. அப்பதான் OH electron pull பண்ண முடியும். So this is minus I group. So 2 is better. Now carbon attached is giving electron from this group. Ingin carbon is giving from this group. So this is a smaller plus I compared to this one. So 4 greater than 1. Alright, now here given are cyclohexanol, acetic acid. So I have an acid, 2,4,6 trinitrophenol, picric acid, phenol. So I know picric acid is stronger than acetic acid, which is stronger than phenol, which is stronger than cyclohexanol. 3,2,4,1. 3,2,4,1. That's all. AIMS 2011 ஈஸியாக இருக்கும் பார்க்கறதுக்கு. Decreasing order of PKB. PKBயில் கேட்குறாங்கன்னா basicityயோட ரிவர்ஸ் தான் PKB. We can put it this way. Basicity is proportional to Kb, inversely proportional to PKB. We will see this detailed in equilibrium lecture. First, let's arrange them in basicity and pick the reverse order. Basicity வேணும்னா எனக்கு என்ன எஃபெக்ட் இருக்கணும்? இதுக்கு ஆப்போசிட்டாக இருக்கணும். I want plus R, plus I, neutral molecule. Okay, let's put it as N, stem, followed by minus I, minus R I don't want. Another thing that you want to know in basicity is alkyl, ammonia, aryl. Okay, first thing you want to look at is alkyl. This is alkyl. So 3 is the largest. That's your answer. See how fast it is. Okay, let's just double check. 3 is fine. Now I need to label these. So this is plus R group. This is plus I. We will see this later. Hyperconjugation la varum. This is going to be weak plus R, weak minus I. Okay, so I know that 3 is greater than weak plus R இருக்கிறதுனால you can look into OCH3 or Cl. Now what you want to see here is this order is very very tricky. 2க்கும் 4க்கும் இருக்கிற order. Okay, AIMSல வந்து ரொம்ப டஃப்பாக இருக்கும் இது. It could be inverted also. PKB values கொடுக்காம சொல்ல முடியாது. But one thing 2க்கும் 4க்கும் because இது plus R but ஆனால் ரொம்ப weak. Okay, we saw this. This is hyperconjugation. okay, but plus R wins over hyperconjugation. We will see this later. Clear it out. Let's do fresh. So I know that basicity order la enna irukum. Basicity order, I know my 3 is the best, correct? Appo PKB la 3 is the worst. Okay, 3. Now there is 3 here, okay, and then there is plus R here. Then there is hyperconjugation plus R minus I. As I told you, 2 and 4 la decide panna mudiyadhu, but 1 ennaal decide panna mudiyum. Okay, this is alkyl amine, so extremely strong base, lowest pKb is the last one. Now here they are saying decreasing order of pKa, same thing, acidity order modalla paakalam, ellame vandu substituted phenol. What makes it more acidic? Minus R group. This minus R, this is plus I. Later we are going to see hyperconjugation. This is going to be minus I because meta position. This is going to be minus I. Stronger minus I is here. So acidity is going to be 3 greater than, alright, 3 greater than, this is the last one, is 2 because plus la irukku. Now who is stronger? 1 is stronger than 4. So pKa is going to be 2 greater than, 4 greater than, 1 greater than 3. Okay, I think this is messed up right there. Because we know that OCH3 is a stronger minus I compared to Cl. Exact effect theriyadu, but this will be the best available option. Okay, aims la vandu questions la mistakes irukum. The reason is because these are questions printed not from question paper. Question paper வெளியில கொடுக்க மாட்டாங்க. It's a computerized exam. So students வந்து வெளியில வந்து சொல்றத வச்சு எழுதுற questions இதெல்லாம். So there will be mistakes in the questions. Doesn't matter. Still we are able to get this answer just from looking at number 2. Alright, now we'll go into few more examples. I know that it's a lot of example, but we have to do examples to get stronger in this. Correct decreasing order of pKb. So they're talking about pKb. pKb na basicity ka opposite. Basicity la modalla paakano appadina you have to look into alkyl amines. So 2, 3 and 4 are alkyl amines. So 2 degree. Methyl ku 2 degree, 1 degree, 3 degree. Remember? So I'm going to have the degree. Options la basicity enna varukum. I will have my 3 stronger base compared to 2, compared to 4, compared to 1. pKb la 1, 4, 2, 3. That's all. Decreasing order of basic strength. Again the same thing. I'm looking for straight up first aliphatic amines. This is aliphatic, this is aliphatic. Adula vandu ring irukku, ring vandu minus I. So I know basic strength la 1 is greater than 2. Idu rendu aniline. Okay, methoxyaniline. Methoxy na plus R irukumla. Idu meta na minus I. Now if I am going too fast, I drew this example some time back. Draw the structure. Maybe I will do it for you. OCH3. This is minus I. So this is minus I. This is plus R. Plus R I want compared to minus I. 1, 2, 3, 4. That's all. Correct order of Kb is again the same thing. My 3 is going to be the strongest base. Correct. So 3 is going to be the strongest base in basicity compared to, this is also alkyl amine attached to a minus I group. 1. Ring is phenol minus I. Then this is aromatic, this is aromatic. So now idu rendathukku nadula ungala solla mudiyala appadina, this is going to be a stronger minus R. In the group enna na minus R. Ring enna minus R. Idu rendume nama paathom lecture la. If you don't remember, go and watch the lecture again. C double bond O is a stronger minus R. So எனக்கு amines ku vandu minus R வேண்டாம். So Kb will be same order. They are not asking you pKb, they are asking you Kb. So 3 greater than, 1 greater than, 2 greater than 4. Which one I'm calling is most acidic? Very simple. Picric acid. And this is NEET 2017. That's all the question is. We can actually do the order. 3 greater than, 2 greater than, 1 greater than 4. Minus R, minus R, minus R, minus R, no effect. Plus I, hyperconjugation later. The correct order of basic strength. This is NEET 2017 question. Na? Basic strength ketirukanga. This is minus R group pulling the electron in. This is plus I group, hyperconjugation plus I giving electron. So my 3 is best. Next is 1, next is 2. Basic strength கேட்டோனே போய் மார்க் பண்ணாதீங்க. PKB கேட்டிருக்காங்களாம் பார்க்கணும். No, basic strength 3 greater than 1 greater than 2. That's all. Now the good thing about this is only set number of examples will keep coming over and over. So in the example la பாத்தீங்கன்னா இதே தான் திருப்பி even I will give in my exams and also the final one. Wordings மட்டும் தான் மாறும். Neatly இதே தான் வரும் உங்களுக்கு. The last segment we are going to see is a special one. Okay, benzoic acid. It's very small concept but nevertheless important. Benzoic acid எடுத்தீங்கன்னா ஒரு acid ஓட acidity எப்படி சொல்லுவோம்? C double bond OH gives you C double bond O minus, and last lecture we saw this is in resonance stabilized form. Okay, so the C double bond O resonance stabilization அதிகமா இருந்ததுன்னா conjugate base இது more acidic இருக்கும். Okay, now is this double bond in conjugation with the OH group? No. இந்த double bond எடுத்துக்கலாம். Double, single, ரெண்டு single வந்ததுல, so this is not in conjugation at all. You want to get this. Benzoic acid இருக்கிற OH is not in conjugation with the ring. The ring is purely a minus I group. It is not a minus R group. Okay. The only thing the ring can do is it can be a plus R. Okay. By giving electron here and going here. So the ring can be a minus I plus R group. Reverse எழுத முடியாது நம்மளால. இந்த பாண்ட் இங்கே போட்டுட்டு இதை இங்கே பண்ண முடியாது. எதனாலனா ஆக்சிஜன் மேலே பாசிட்டிவ் சார்ஜ், கார்பன் மேலே நெகட்டிவ் சார்ஜ் வர முடியாது. Hence this is the way. So minus I plus R. Why does it matter then plus R if this group is not attached? This is the carefully you want to look at it. Now why do you say this is a good acid? Because in the double bond O stabilizes this minus. Correct? But what if the double bond O is in conjugation with the ring? அப்போ இந்த எஃபெக்ட் கம்மியாக இருக்கும்ல, எனக்கு இந்த எஃபெக்ட் அதிகமாக இருக்கணும், இந்த plus R கம்மியாக இருக்கணும். Then benzoic acid will be stronger. Okay, because of this peculiar effect, benzoic acid is important. Now you want to write down here, is the conjugate base stabilized by the ring? No, you want to say that the ring actually participates in resonance with this double bond O, not the OH. The conjugate base is not stabilized. Okay, if at all, and the ring plus R group destabilizes the conjugate base. Now here is an example. Now if you see, this will help you understand better. Now if suppose the ring is helping, ring on the minus I தானே, minus I அப்படின்னா HCO OH formic acid, acetic acid. Imagine இது plus I, இது neutral எடுத்துக்கலாம். அப்போ ring minus I அப்படின்னா ring electron வாங்குதுன்னா benzoic acid should be a stronger acid than formic acid, but that's not the case. Formic acid, benzoic acid, acetic acid. Formic acid is stronger because the minus I of the ring helps in becoming a better acid, but it is ruined by the plus R of the ring also. It gives the electron. Okay, so this is something you want to remember. Formic acid is a stronger acid than benzoic acid, even though the ring is minus I, because minus R of the ring cancels out the minus I. Now this is very simple. Electron withdrawing group like NO2 in the para position increases acidity because inductive effect. That's all. See, the inductive effect நான் கொடுத்திருக்கேன். I did not give you resonance effect because there is no resonance. Same, electron withdrawing group இருந்தா acidity increase ஆகும். Electron donating group இருந்தா acidity decrease ஆகும். This can go for meta as well. Para and meta. Ortho alone is a separate question altogether. Now look at it for a para substituted benzoic acid. Higher pKa lower acidity, lower pKa higher acidity. Very simple. இது எல்லாமே வந்து minus I effect தானே, இதெல்லாம் minus I, weak minus I, strong plus I. Okay, you can do it. Now let's do a couple of examples based on this. I'll get all the examples. Okay, let's go to this one. Correct order of acidic strength. I'm going to label them. This is plus R. This is plus I hyperconjugation. Put HC, we will know it later. This is plus I hyperconjugation. This is minus R. Okay. Now you want to be very careful here. This is acid, this is phenol. So obviously acid is more stronger. In the ரெண்டுமே stronger இருக்கும் phenol ஓட. Okay, so because they are stronger, I know that acidic strength 1 is going to be decreased because of plus R effect. Ring உள்ள plus R வரதுனால ring வந்து electron pump பண்ண போகுது. So this is going to be less. So 2 is better than 1. So this is good. Now இங்கே போகும்போது I know my 4 is minus R, which helps my phenol compared to this. So this is the option. This is the part that is going to be tricky. இது ரெண்டும் acid தனியா பார்க்கணும், இது ரெண்டும் phenol தனியா பார்க்கணும். You will get there slowly. pKa increases. pKa அதிகமாகணும்னா acidity என்ன ஆகணும்? கம்மி ஆகணும். Acidity decreases in benzoic acid. The substituent X bonded to para position. அப்போ X என்னன்னு கேட்குறாங்க. அப்போ X என்னவா இருக்கணும்? Acidity எப்போ கம்மியாகும்? ப்ளஸ் ஆராக இருக்கணும், இல்லை ப்ளஸ் ஐயாக இருக்கணும், இல்லைனா weak minus R among the given group. But here it is very simple. This is plus R. Which will be the lowest pKa? This one. Okay. Acidic order என்னன்னு பார்த்தா 2 greater than 3 greater than 1 greater than 4. pKa opposite. Compare the acidic strength of the given acid. So எல்லாமே பார்க்கும்போது this is actually substituted acetic acid. This is acetic acid. This is benzoic acid. This is benzoic acid. But I have a minus I group here. So my 3 is the best compared to 4. Because when I look at benzoic acid, it is better than acetic acid. We saw that before. Okay. Now this is a minus I group. This is no effect. Or plus I group. No check. So greater than 2 greater than 1. 3 4 2 1 alpha. These are pre-VQ questions. I have already sent you this as well. Regardless, do it along with me. The last effect we are going to see, para மட்டும் இப்போ பார்த்தோம், para on meta. Ortho effect வந்து தனியாக இருக்கும். ஆர்த்தோவில் வந்து ஒரு பல்கி குரூப் இருந்ததுன்னா அந்த COH வந்து out of plane போயிடும். See, this rotates 90 degrees. Now this is an important concept. Ortho effect you want to write down here helps acidity. The reason is, remember we saw this before. Sorry, C double bond O OH. This is actually in conjugation with the double bond O. In the conjugation இருக்கனால acid ஓட strength கம்மியாகுது. What if I move the ring out of plane? இந்த மாதிரி மாறிட்டா இந்த conjugation நடக்காதுல, planarity போயிடும். Because of loss of conjugation with the ring, acidity increases. So big ortho substituent will increase acidity. அதில் ரெண்டு இருந்ததுன்னா இன்னுமே நல்லா திரும்பும். ஒன்று இருந்தால் it will rotate a little, ரெண்டு இருந்தால் 90 degrees திரும்பிடும் because of the steric reason. They hit each other. Okay, this you want to remember. That's what is given here. Now when you see here, I'll take this. Nitro, இது என்ன? Minus I. இது minus R. This is minus R, minus I. Also ortho effect. But most importantly, this is plus sign வச்சுக்கலாம். Hyperconjugation வரும். This is purely plus I. This is reference. This is plus I hyperconjugation. Now plus I இருந்தால் acidity கம்மி ஆகணும். So benzoic acid பக்கத்தில் உங்களுக்கு என்ன ஆர்டரில் இருந்திருக்கணும்னா, you should have gotten para, meta, ortho. இதுதானே டிஸ்டன்ஸு I effectuக்கு. பட் இங்கே இருக்கிற ஆக்சுவல் ஆர்டர் என்ன? You have ortho greater than, benzoic acid greater than, meta greater than para. Correct? The reason is ortho effect இங்கே. Okay, so because of ortho effect it comes here. What about these two? This is where the hyperconjugation principle is going to come later. Hyperconjugation para is actually, it's in conjugation, so it is going to change. We will see this alone separately. At this point உங்களுக்கு ortho effect நால ortho substituted benzoic acid is going to be stronger acid. You have to remember. Now this is a beautiful example and the exception is there. Now take for example, these three are same. Correct? What is the effect of chlorine? Plus R minus I. இங்கே வெறும் minus I, இங்கே வெறும் plus R. So I want my plus R to be there or not. I don't want the plus R. அப்போ minus I மட்டும்தான் எனக்கு வேணும். எனக்கு அப்போ என்ன ஆர்டரில் இருந்திருக்கணும் அப்படின்னா expected meta greater than para greater than ortho. Okay, actually sorry, expected வந்து meta greater than ortho greater than para. ஏன்னா plus R இருக்கு, minus I at least helps me. So this actual என்ன இருக்கு, ortho greater than meta greater than para. The only thing that has changed is this because of ortho effect. Same thing here, if you see ortho, meta, para, pKa values corresponding. Okay, one thing I want to say here, ortho nitrophenol has hydrogen bonding, so acidity kamiyagum. Ortho nitrobenzoic acid does not have hydrogen bonding effectively because of orientation. So do not confuse hydrogen bonding. Ortho nitrobenzoic acid does not have intramolecular hydrogen bonding. This is an important example. Okay, here what is the order that you would expect? This is effect irukuna plus R minus I. This is minus I. This is plus R. So expected order enna irukum? Enak minus I is better than no plus R. So meta greater than ortho greater than para. And next minus I can vanda. But actual enna irukku? Look at the values. Okay, you have meta greater than para greater than ortho. This is completely different than any of them. Correct? pKa values வந்து இதுக்கு தான் அதிகமாக இருக்குன்னா acidity கம்மியாக இருக்குது. Very simple. What's changing here is expected ortho மட்டும் கம்மியாகிடுது. இங்கே ortho effect இருக்கும். இங்கே ortho effect இருக்கும். But when this turns, there is hydrogen bonding in this compound. Okay, because of hydrogen bonding, the acidity decreases. It's tough, but you will get it there. Don't worry. First week மட்டும் தான் tough இருக்கும். Same examples. Once you are done, there is no way they can confuse you. Same examples keep repeating. Okay. Now this is what I meant. There is hydrogen bonding. Because of that, the acidity is less than what we expect. Ortho effect இருந்தாலும் acidity கம்மியாக இருக்கும். Alright, we have seen the basics of mesomeric effect. I know it is little confusing, but if you practice, you'll be fine. This is a lecture that you have to watch it few times. இது கன்ஃபியூசிங்காக இருந்தது, இதிலேருந்து நீங்கள் கிளாரிட்டி கிடைக்கலன்னா ஆர்கானிக் கெமிஸ்ட்ரி பின்னாடி டஃப்பாக இருக்கும். ஸோ மேக் ஷூர் யூ வாட்ச் இட் ஃபியூ டைம்ஸ். ஐ எம் செப்பரேட்டிங் இட் இன்டூ பார்ட்ஸ் ஸோ தட் யூ டோன்ட் கன்ஃபியூஸ் இட். இது ஸ்ட்ராங்காக ஆகலைன்னா நெக்ஸ்ட்டு பார்க்க போகிற எலக்ட்ரோஃபிலிக் அரோமேட்டிக் சப்ஸ்டிடியூஷன் கன்ஃபியூசிங்காக இருக்கும். ஸோ மேக் ஷூர் யூ வாட்ச் இட் அண்ட் ஆல்சோ சால்வ் தி ஒர்க் ஷீட் ஐ ஹவ் சென்ட் யூ கைஸ். Thank you.